Hey, just imagine you have terabytes of data and you run a query on that. So normally it will take hours to process. But in BigQuery, the same thing will be done in just few seconds. So seems to be magic, right? Absolutely not. Because of the BigQuery architecture, this makes the BigQuery to process the massive amount of data just in matter of seconds. Right now, what actually happens when you run a SQL query inside a BigQuery? I mean, when you just execute a simple select statements, which will process the massive, that is terabytes of data in just matter of seconds. So what's happening under the hood? I mean, where is your storage, right? And where is your compute? And then how the compute and storage are interconnected, and what makes the Google Cloud BigQuery to process the massive amount of data in just matter of few seconds. So let's explore everything through this video, right, in the most simplest way, and which is absolutely for the the beginners, right? So now you may ask a question, why exactly we need to understand the BigQuery architecture, right? Because see, BigQuery is heart of data engineering, that's for sure. There is no ifs and but. And if you want to attempt for the Google Cloud's data engineer certification exam, then the questions will not be direct there, guys. I mean, they will ask the questions in the form of use case. And to understand that use case, you must know the architecture of BigQuery so that you can attempt the question and you can attempt the right answer as well. Right, so let's explore about the BigQuery architecture in most simplest way as possible so that you can understand it for a long time, and this will definitely help you to crack or to become a professional data engineer and crack the certification exam, and absolutely important for the interview point of view as well. So without wasting any time, let's move on to the video. Aspect, that is the BigQuery architecture. So the big question here is, what makes BigQuery so unique in its architecture? Yeah. So the unique part of BigQuery architecture is the storage part and the compute part are completely separated. Okay. So this has divided into two sections. One is a compute part where exactly the computation happens, and one is the storage part. In that storage part, there is only data stored, there is no computational aspect on there, only the data store, and it's a dedicated one. Compute part is just for computational and storage part is just to store the data, right? So let me do here. All right, so here you can see this is the architecture of BigQuery in this image, and this part is known as the computation part, which is called the brain of the BigQuery architecture, and this part is the storage part. Here only the data is stored in the form of columnar storage. Sounds good. Then how these two are connected? These are connected through a petabit network, which is a very high scalable network, and this network is called the Jupyter network. No need to go in depth on this, but just try to understand that the compute and the storage are separated. Now if you see how the compute section is organized by itself, right? So the compute section has got so many nodes. So these are called independent nodes, or you can call them as the worker nodes or workers or computational units or computational resources, however you like. These are typically the machines, yeah, or slots. You can call them as slots or machines or workers, anything you want, but try to understand the concept. That's very important, right? And here in the compute section, these are not fixed. Okay, these are not fixed. Okay, this compute section has got pool of these worker nodes, yeah, and these worker nodes will work parallelly to compute a job and give you the results. Okay, so let's discuss the same concept, what happens when you run a query under the hood in BigQuery and you will get the results. Let's discuss that in a blackboard. Let me add a new page. Now here we have a compute part and we have the storage part. Okay, try to understand this very thoroughly. Here only the data is stored, right? There is no computational concept here. Here there is only computational concept, no data is stored here. Now what happens under the hood is, when you run a SQL query, this could be the the query job, or copy job, or extract job, or load job. Internally this SQL statement gets converted into a job. Very important. Internally this SQL statement gets converted into a job, and this job is submitted to the compute section. Now inside a compute section there is one root node. Okay, I will call this as a manager. Okay, just for your understanding purpose, it's not a manager node or something, it's the root node, or there is one specific term involved, we can check it, but try to understand the concept. There is one main node or master node or the root node who works as a manager, right? The basic thing of the manager is, he will check the job and he will decide how much complex the job is. Once he understands the complexity of the job, this guy will segregate or splits the job into number of subtasks. Okay, then this person also decide, in order to execute this job parallelly, how many resource workers I need. Okay, assume that looking at this job complexity, this person decides, okay, I want 3 workers, right? I want 3 workers. It means I want 3 additional nodes in order to carry out this job. I said nodes are nothing but the computational resources or slots or workers, whatever you call, but I call in this analogy as the workers. Now the manager comes to know that, okay, in order to execute this job I want 3 slots or 3 workers or 3 computational resources. Now this manager assign the task to these 3 worker nodes. Okay, it means this manager assign each subtask to person A, node B, node C, or worker A, worker B, and worker C. What happens? These workers executes the job independently and parallelly. This is extremely important. These worker nodes will execute the job or the subtask assigned to them parallelly. Okay, they work the task parallelly. Okay, and then once the task is done, their results are combined together, and this will be your output, which is shown on the console. Okay, I repeat one more time, listen it very carefully. You submit a job or you write a statement in SQL. Internally this will get converted into job, point number 1. Point number 2, this job is submitted to the compute section. Okay, so this is all the compute section. Inside the compute section, there is one root node which accepts the job, and this root node acts as a manager, and this manager decides the complexity of the job. And the manager say, okay, this job is, the complexity of the job is too much, then I want 3 resources in order to execute this task efficiently. It's the count is not always 3. Based on the complexity, the manager in the runtime decide, okay, I want 3 extra nodes or 3 resources in order to execute this job. Then the manager will divide the task, okay, into subtask, and he will assign each subtask to the individual nodes or the individual workers, and these worker nodes will perform the task independently, individually, and parallelly, so that the execution is very fast. And then the BigQuery will combine the results worked by three independent resources or worker nodes, and this will give the output in the console. So this is what happens when you trigger any SQL statement under the hood in BigQuery architecture. And during this job, these worker nodes have to communicate with the storage in order to process the data, in order to get the data, or they want any data push, get the data from storage. They will independently connect to the storage for data processing. So the thing is very simple. Job SQL, job manager divides the task or the job based on the complexity, and it will assign the subtask to the individual nodes. These guys perform the work parallelly and independently, and based on the requirement they may or may not communicate with the storage in order to get the data or process the data, and the results of all three worker nodes are combined together, and this will be shown as the output of your SQL query. So this all happens under the hood, and the execution is so fast that you cannot even imagine like how fast it is working under the hood. So this make BigQuery very special, very efficient, and very fast. So thank you guys, that's all in today's session. So in the next session we are going to look on the different types of tables we have in BigQuery and what do we understand by the federated queries. All right. Oh, sorry. I just forgot the next image here. So whatever I have explained in the blackboard, this is the same replica of that, but this is too much technical to understand at the first go. That's the reason I made a simple understanding on the blackboard. At least you guys understand the concept well, right? So the same thing here, see, SQL statement converted to a job, submitted to a root server. This guy is a manager, and once the manager accepts or receive the job, and the manager will convert the job into execution tree like structure. Okay, so this is the execution tree where these are the workers. Okay, independent workers. These independent workers will perform the task independently and parallelly, and if they want to lift the data from the storage, they can lift, or it's not mandatory that they have to lift the data or they have to communicate with the storage part. Okay, that all depends on what kind of the statement you have written. Okay, so this is more technical, which is present in official documentation. I urge or request all to refer to this documentation from online, but whatever I have explained on the blackboard, that is just for your understanding purpose and for your real world analogy. Make sense? All right.